Welcome again. So in today's class we will be seeing about how to find the equivalent resistance in series as well as parallel condition. So you can see this problem. Find the equivalent resistance for the following figure and find the total current. So this is the network given. So you have a 10 volt voltage source, 1 ohm resistance, 2, 3, 4, 5 ohm resistances. So you have only one source. Negative is here, positive is here. Current flow from negative to positive. So the current that is produced by this source will be flowing along this direction. The same current will be flowing through this, the same current will be flowing through this, same current will be flowing through this, same current will be flowing, same current will be flowing, and it will be reaching here. So all the resistors same current have flown through all the resistors. So we will say all these resistors are in series. So you can easily add all the resistors. So R equal to 1 plus 2 plus 3 plus 4 plus 5. The value of all these resistors. So that will give you R equivalent. Now we want to find out the total current also. So that's Ohm's law. I equal to V by R. R you have found out 15. V that is here the voltage source 10. Just substitute it, simplify it, you will get the answer. Very simple problem. Check this problem. Find the equivalent resistance and total current in the circuit. So you have a 10 volt resistor, you have a 10 volt source, 2 ohm resistor, 3 ohm resistor and 4 ohm resistor. So this will be also producing a current. So this current will be flowing here, it will be coming here, and here it will be divided into two. One portion of this current will be flowing across this and the rest will be flowing here. What is flowing here will be again divided into two. One will be flowing here and another will be flowing here. So different current flows through these three resistors. So they are said to be in parallel. So we know the equivalent is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by 2 plus 1 by 3 plus 1 by 4. If you simplify it, you will get the value of R equivalent. So to find the current, again we want to use Ohm's law. I equal to V by R. So V is there in the question. R is what you have found out. Just substitute it, you will get the value of current. Now check out this problem. Find the equivalent resistance between points A and B shown in the figure. So point A is here, point B is here. We can start from A and we can try to reach B. So through A, if a current is applied, this current will be coming here. It will be divided into two. One portion of the current will be flowing here. After reaching this point, again it will be divided into 3 and it will be coming here. The current what came here will be again divided into 2. One will be flowing here, one will be flowing here. What is coming here will be flowing across these two resistors and it will reach B. What is coming here will flow across this resistor and it will reach B. So that's it. So here the thing you want to understand is we want to reduce from the shortest loop. So here current is coming here, it is getting divided into 2 and one portion is coming here and it is divided into 3. So first we can simplify this. So different current flows through these three resistors. So they are in parallel. So you can find the equivalent of this. So 1 by R equal to 1 by 3 plus 1 by 4 plus 1 by 4. Simplify it, you will get the value of this. So you can again redraw this diagram. So its value is 1.2. So you can draw here. Now again you can check this. Current is applied here, this current comes here, it is again divided between these two. So what is coming here will be flowing across these two resistors. So these two resistors are in series. Similarly, what current is flowing through this will be same across these two resistors. So these two are in series. So you can add these two, you can add these two. So 2 plus 1.2 will give you 3.2, 5 plus 6 will give you 11. So these two and 7 is there, you can put it. Now again you can check. Current will be flowing from here, it will be coming here, it will be divided into 3. So 3 resistors are in parallel. So again you can find the equivalent. So 1 by R equal to 1 by 3.2 plus 1 by 11 plus 1 by 7. Simplify this, you will get this. So now you will have this 1 ohm resistance and the 1.83 ohm resistor. Now if you apply current through this, same current will be flowing through this and it will reach B. So you can add these two, you will get this. So this is your final answer. Very simple problem. Now you can check this problem. Calculate the equivalent resistance and current in the following figure. So 50 volt, there is a voltage source. So it produces a current. This current is coming in this direction. It will be divided here as well as here as well as here. So we know we want to start from the smallest loop. So first current comes here, it divides between this and this. So these two are in parallel. So you can simplify it, you will get this. So these two resistors are replaced by a single resistance 4 ohm. Now you can see this 4 ohm and this 16 both are in series. You can add them, you will get 20. Replace the remaining components. Now these two are in parallel. You can draw it. Now these two will be in series. Add it. Find the current. Very simple problem. Now check this problem. Find R equivalent and current flow due to 12 volt source. So you have a 12 volt source, 24 ohm resistor, 100 ohm resistor, 55, 10 ohm resistors. So this one produces a current. This current flows here. It comes here and it is dividing between these two. What comes here will be again dividing between these two. So we can start from this. So 5 and 10 both are in parallel. You can simplify it, you will get this. Instead of these two resistors, you draw this. Now this current will be coming here, it will be dividing between these two. What flows here will be flowing through this. So these two are in series. So you can add these two, you can draw it here. Again you can see current I comes here, it's coming here and it is dividing between these two. So these two are in parallel. You can simplify it and you can find the value. So instead of these two resistors, you can put a single resistance. Now current flows through this, the same current will be flowing through this. So both are in series, you can add it. So you can replace the circuit like this. Now you have voltage and resistance. You can find the current I equal to V by R. Very simple problem. Now you can check this problem. The total power dissipated in the circuit is 18 watt. So power is given. Find the value of R and the current through it. So here one value of resistance is unknown, R. So 12 volt is voltage is given. 8 ohm and 1 R both are in parallel. 4 ohm and 16 both are in parallel. So we want to find out what is R. We know power is given by I square into R. So from Ohm's law, I equal to V by R. So we can substitute this value of V by R here. So you can simplify it and we will get this. So from this we can find out what is R. So R equal to V square by P. So this R is nothing but the equivalent resistance. So R equivalent equal to V square by P. So in the question, so this was the problem. So here R equivalent equal to V square by P. So voltage 12 volt, that is given in the question itself. Power is also given in the question 18 watts. So we can find out R equivalent. So that is the equivalent resistance. Now R equivalent. So in this circuit, if you are going to find out the equivalent resistance, then these two resistors are in parallel and these two resistors are in parallel, both are in series. So R equivalent equal to 8R divided by 8 plus R plus 16 into 4 divided by 16 plus 4. So you can simplify this. So here only R is the unknown. You can simplify it and you can find out what is R. Similarly, you can find out the current I equal to V by R equivalent. You can find the current. So this is also a similar problem like what you have seen here. So find the unknown resistance and current through the circuit, assuming total power is 20 watt. So power is given 50 volt, it's also given. This resistance is unknown. So here current flows here, it comes here, it divides here. So these two are parallel. everything joins here. So this is plus, again it will be dividing here. So these two are parallel and these two are parallel, and these two parallel combination are in series. So similar to what you have seen earlier, we want to solve it. So power, using this you can find out what is R equivalent, you can find out what is R, you can find out what is current. Now check out this last problem. Find the equivalent resistance between A and B. So A is here, B is here. So if you are applying a current through A, it will be splitting between these two. So these two are in parallel. Similarly, if you are supplying a current through B, it will be splitting between this and this. So these two are in parallel. Due to the presence of this, you can say both are in series. So this parallel combination and this parallel combination, both will be in series. So you can redraw this diagram like this. So these two are in parallel, you can find its value. These two are in parallel, you can find its value. Put it in series, add both, there will be your resultant. Very simple problem. Thanks for listening.